We're on trigonometry. And first thing we have to learn here is the trig functions, the trigonometric functions. We have 6 of them. So the first one, I'm going to write the full name and also the shorts, the way we write it here and why solving. So the first one is sine. So the short form is sine. We have cosine. Short form is cos. We have tangent. Short form is tan. We have cosecant. The short form is cosec. So, or some write it CSE. So we have secant. The short form is sec. And finally, cotangent. The short form is cot. But we normally attach an angle. So, sine of an angle. So, assuming we have a right angle triangle, let's call the angle here theta. So, assuming the sides of the triangles are A, B, and C. So, there's one acronym before now. I believe we conversant with this acronym so. So S here is sine and is always opposite. So which one is the opposite of the side of the triangle? The opposite is the side opposite the extra angle added, not the one opposite 90 degrees. That extra angle, which is theta. So this is opposite. YB is now the adjacent opposite. This is the adjacent. Yes, why this? The longest side is always the hypotenuse. So now we have the sine of the angle, which is theta, is always opposite, which is A over C. Cos of the angle, cosine theta, is always B over C. While cot tan theta is always A over B. But if you look at it, A over B could be written as A over C divided by B over C. Yes. So what's the implication? So it shows that tan is always sine, because if you notice, sine is A over C over cos. So it's called the quotient identity. So tan is always sine over cos. So we'll continue. We now have the remaining 3 are reciprocal identities. Yes. So we have cosec theta. Cosec is 1 over sine. So that is reciprocal. The remaining 3 are reciprocal identities. So that's the thing. So which is C over A. We have secant theta. Sec theta is 1 over cos, which is C over B. And the last one is cot. Cot is 1 over tan. And from what we've done, since tan is sine over cos, cot will be cos over sine. So these are the 6 trig functions we have. So let's look at what we call Pythagorean identity. So Pythagorean identity, let's start with leveling the side, assuming the angle here is theta. Let this A, B, and C. So everybody here knows that there's one theorem we are conversant with. It's called Pythagorean theorem. So that A squared plus B squared is equal to C squared. It's called Pythagorean. So this 6 identity is based on that. So now the Pythagorean identities are the first one. We have 3 of them. That's sine squared plus cosine squared is equal to 1. So, but before then, sine squared in 3, we normally write the power that's equal to write the power sine, the sine theta raised to power something, let's call it m. We normally write it in between the trig function and the angle. Yes. So that's how it's written. So that's the first part. Now this thing means sine theta all squared, and this cos theta all squared is the same as sine squared. So the first one is this, while the second one is 1 plus tan squared equal to 6 squared. The last one is 1 plus cot squared is equal to 6 squared. So these are what we call Pythagorean identities. Pythagorean identities. If you look at it, it looks like Pythagorean theorem. Yes, check. I believe that's why it's called Pythagorean identity. Because the sum of square gave us another square. Sine square plus cos squared is 1. 1 is 1 squared. The same thing. 1 is 1 squared plus tan squared gave us 6 squared. 1 squared plus cot squared gave us 6 squared. You see the base Pythagorean identity. So let's look at the proof, just the quick proof of that. So we want to show that sine squared plus cos squared is 1. Yes. So first of all, we see that let's prove this. So let's just start proving. Let's know whether we'll get 1. So sine is opposite, which is A over B, A over C, not B. A over C all squared plus B over C all squared. So this is now A squared over C squared. This is B squared over C squared. This is now A squared plus B squared all over C squared. Now we're written from Pythagorean identity, Pythagorean theorem, that A squared plus B squared is C squared. So C squared over C squared. So the answer is 1. So we've proved the first one. So why the second one? Prove this first one. Let's now divide what we've gotten by sine squared. Yes. Well, let's start with cos squared. Okay. Let's divide. We've gotten that sine squared plus cos squared is 1. So let's divide both sides by cos squared. So what do you observe? Sine squared over cos squared is tan squared, yes. It's cos squared because square is common in both. You can factor raise the sine over cos is tan. So because of the squared. So why this is 1? 1 plus cosec squared is now sec squared. Because 1 over cos is sec. So we've proved the second one. So why the last one? The same sine squared plus cos squared equals to 1. If we now divide by sine squared, what do you observe? Sine over sine is 1. Cos over sine is, remember, is cos. Yes. Cos over sine is cos. So because of the square, it's now cos squared. So 1 over sine is cosec, so we will have cosec squared. So we've proved the identities. So that's it. So let's look at this question. As if sine x is 1 over 9, then we should evaluate this. Okay, we want to evaluate that. So first, use white. And what we've done, 1 plus tan squared is sec squared. Yes. And 1 plus cos squared is cosec squared. And we know that sec is 1 over cos. So 1 over sec is now cos. So cos squared. Why cosec is 1 over sine, meaning that 1 over cosec is now sine, so I have sine squared. Now, from our Pythagorean identity, the first one, this is equal to 1. So we don't even need this sine x is 1 over 9. With the identity, we've proved it first. So that's the answer, option B. Okay, we are asked if cosec x plus cot x is equal to half. We are now asked to find cot x minus cosec x. Okay. First of all, we are given that cosec x plus cot x is half. And we can still write this as 2 is equal to 1 over cosec x plus x, yes. Because assuming we cross multiply, cosec x plus cot x times 2 is 2 times cosec x plus cot x. So just swapped. So we're still correct. And now, we can write 1 as cosec squared x minus cot squared x, yes. From Pythagorean identity x. From a Pythagorean identity, that's 1 plus cot squared is equal to cosec squared. So we are still correct. So if we now make 1, the subject of formula is now cosec squared minus cot squared. And looking at this is difference of 2 squared. So which is now cosec s plus cot x times cosec x minus cot x. over cosec x plus cos x. Yes, from difference of two square. From a square minus b square is a plus b minus a minus b, difference of two square. So we are still correct. So let's finish it together. Remember this 2. So we now have 2 is equal to the common term is off. So we are left with cosec x minus cos x. Well, we're asked to find cot x minus cosec x. So the other way around. Therefore, cot x minus cosec x now be minus 2. Yes. As if we move the 2 to the left hand side, it's now cot x minus cosec x. Why 2 goes to the right hand side to be reduced. So that's our answer, option B. Tricky one.
As if A equals x sine theta and B equals y tan theta, then we have to find x squared over A squared minus y squared over B squared. So this is the equation on trigonometry. Okay, we'll start. So we are given that A equals x sine theta. So from here I'm seeing x squared over A squared. So I can make x over A the subject of formula. So from here, x over A is now 1 over sine theta. And 1 over sine theta, 1 over sine is cosec. So that's the first thing. Y here, I'm seeing y over b. So we have and y and b equals y tan theta. So the same way, making y over b the subject of formula, y over b equals 1 over tan theta. Again, we know that 1 over tan is cot. So if you square from here, we are given x squared over x squared minus, which could be written as, you can write it as x over a all squared minus y over b all squared. I've known that x over a is cosec, so I have cosec squared theta minus y over b is cot theta, so I have cot squared theta. And from our Pythagorean identity, cosec squared minus cot squared is 1. Yes. We have 3 Pythagorean identity. We have that sine squared theta plus cos squared theta is 1. We have that 1 plus tan squared theta is sec squared theta. And we have that 1 plus cot squared theta, that's cot squared theta plus 1 equal to cosec. So these are called Pythagorean identities. So that's why we said cosec squared minus cot squared is 1. So that's how I got 1. Our answer is option A. Thank you.
So we're on complementary or cofunction identity. Okay, before now, let's go back. Before now, we know that assuming you have a triangle ABC with this angle theta, and this identifies from this acronym SOCA2, we got this. So assuming we now want to write the second angle, that's the one aside 90 and theta. I think it should be 90 minus theta, yes. So see what I'm saying? Since we've called here theta, so let's call the remaining angle here. So since here is theta, is now 90 minus theta, yes. And the sides are A, B, and C. So now, based on what we've done, so our opposite now is, if we take this as opposite, that's B is our opposite because the angle we're using is now 90 minus theta. So we have that sine 90 minus theta. Opposite is now B and the hypotenuse is still sine. So we have cos 90 minus theta will now be A over C, y tan 90 minus theta is now B over A. So again, cosec 90 minus theta will now be C over B, y sec 90 minus theta will be C over A. So cos 90 minus theta will now be A over B. So what do you observe? So if you check the former diagram, we still have B over C. There's one with B over C. There's one with A over C. There's one with B over A. So let's check back. We'll now compare the results. So which one gave us B over C? You see that cos theta is B over C, y sin theta is A over C. So let's go back. So do you see now? So therefore, let's give this a space. Remember, from what we've just checked now, B over C is now cos theta because we're using the same triangle. This is the same triangle as the former one, the same thing. So y A over C is sine. And we see is cot. B over A is cot. Check. Okay, I didn't even write one over it, so it should be B over A. So this tan is A over B. So do you see? So these are the, from here you see is what? Cosec with the sec theta. Y sec is cosec theta. Cot is tan theta. So these are what we call complementary or cofunction identities. You see, so we have 6 of them. So let's use it as solve question. Okay. Look at this question. Look at this question. It has to find x if sine x is cos 4x. Okay. From what I've just done, solve sine and cos that are related, yes. So I can convert sine. You know they give us sine x is equal to cos 4x. I can convert sine to cos, which is what? Which is now cos 90 minus x. I did it so that both left and right will have the same. So this is now easy because what we have here is cos and what we have here is cos. So the angles must be the same. So 90 minus x must be equal to 4x. So this one crosses to be plus 4x plus x is 5x. Remember 90 degree. So answer is 90 over 5, which is 18. So the answer is option A. So that's it for the function identity.
So we're asked to evaluate this without a calculator. So we can do this using two identities in trigonometry. So the first identity is that sine squared plus cos squared is 1. It's called Pythagorean identity. If you look at it, it looks like Pythagorean theorem. So that's it. Another one is what we call cofunction or complementary identity. So that if you have sine theta, it's the same thing as cos 90 minus theta. Or that if you have cos theta, it's sine 90 minus theta. So this is called cofunction or complementary identities. So that's what you're going to use in solving this question. From here, you can see that sine squared 33 is the same as cos squared 90 minus 33. Yes. So which is the same as cos squared 57. Yes. And again, if you look at cos squared 73, is the same thing as sine squared 90 minus 73. We are using the cofunction identity. So which is sine squared 17. So what do you notice? You see that this will be 1. Therefore, sine squared 33 is cos squared 57 plus y cos squared 73 is sine squared 17 over, we'll repeat the denominator. So have you seen it's the same? So this is 1. So coming here, we'll repeat this sine squared 5 plus sine 85 is cos 90 minus 85. Yes. So I'm saying that sine 85 is the same thing as cos 90 minus 85, which is cos 5. So this is now cos 5 times cos 5, which is cos squared 5 degrees. And from this, you see that our answer, this is 1, while this is also 1. So the answer is 2. So it's a very tricky question. It's a nice question, but tricky. Thank you.
As if sine x equals m over n, what is sine 90 minus x? So we're going to use both the function identity and Pythagorean identity. Yes. So we're asked to find sine 90 minus x. And from our cofunction identity is cos x, if you can remember. Now, from Pythagorean identity, we know that sine squared x plus cos squared x is 1. So therefore, this is now equal to the square root of 1 minus the square root of x. So this is based on Pythagorean identity. That is sine squared x plus cos squared x is equal to 1. Yes. So now we'll substitute the value. The value of sine is m over x. So we'll have square root of 1 minus m over n all squared, which is square root of 1 minus m squared over n squared. So from this, LCM is n squared, so we have n squared minus m squared. Since the square root of n squared is n, so we're left with that. N squared minus m squared. So that's option D. So we combine both Pythagorean identity and cofunction identity. So let's now move to quadrants. Let's move to quadrants. So because our main aim is, if we are given angles higher than 90, so we have a quadrant now. We have 4 quadrants, total of 4 quadrants. So the one here is the first. This is the first quadrant. This is the second. This is the third. This is the fourth. So each of them, the angle here is 90, 90, 90. Though we move counterclockwise. Yes, we move it the other way. See? So that's first, second, third, fourth. So we should know that all the trig functions, they are all positive on the first quadrant. In the first quadrant, all whether sine, cosine, tan, sec, cosec, cot, they are all positive. So, and the angles will be between 0 and 90. So any angle within the range of 0 to 90 is in first quadrant, while the second one from 90 point something to 180, so 90 without including 90. So the maximum is 180. The third quadrant, we have angles within this range. So the maximum is 270. So anything greater than 180 and less than 270 or equal to 270, less than or equal to. While the fourth quadrant, we have 270, 37, less than or equal to 360. So these are the range of angles in each of the quadrants. So know when the angle is in which quadrant. So another thing you have to know that only sine and its reciprocal, which is cosec, they are the ones positive in the second quadrant. So it's only sine and cosec, that's the reciprocal, they are positive. Others are negative. Coming to third quadrant, only tan and its reciprocal, which is cot, they are the ones positive. The last one, so we are eliminating cos and sec. They are the ones positive, others are negative in the fourth one. So the final thing we have to know here, because, from the quadrant, don't normally have problem in first quadrant. So angles within second, third, and fourth quadrant, we need to convert it to a first quadrant angle. Yes. And how do you do this? By using this. So in second quadrant, so the actual angle you are going to use now, the actual angle is now 180 minus the given angle. Yes. Why in third quadrant, the actual angle you are going to use now will be the given angle minus 180 degrees. Yes. So that will automatically convert it to first quadrant angle. Why the last one? The actual angle you are going to use will be 360. 360 degree minus the given angle. Yes. So let's look at this question so that you understand how to apply that. Okay, look at this. We're asked to find the equivalent of the following. So we won't get the exact value, just the equivalent. So the first one, we are given sec 253. So sec, we can write it as 1 over cos. Yes, let's start with that. And 253 is in which quadrant? From the range is in the third quadrant, yes. So, and in third quadrant, what happened? You do the given angle, which is 253 minus 180, yes. And also, which trig function is positive, or which trig functions are positive? Only tan and cos. So, but they gave us cos, so it's now minus cos. So the answer will now be minus 1 over cos 253 minus 180 is 73. So that's the equivalent. It's equivalent to minus 1 over cos 73. Why the second one? We have cot 300. So cot is 1 over tan. And now, which quadrant? 300 is in which quadrant? Fourth quadrant. So we have, and tan is negative there. So I have minus tan. It's only cos and sec are positive. So we now have 360 minus the given angle is 300. So we are using this, we're using our formula here. Actual angle is 360 minus the given is 300. So answer is minus 1 over 60. For now, we don't know the value of tan 60 for now. We'll still do it later. So y c 140 cosec 140. So 140 is in what quadrant? Is in which quadrant? 140 is in which quadrant? Second. And cosec is 1 over sine. So, and we know cosec and sine. Cosec and sine are positive there. So we now retain the positives. And 1/8 we now subtract the given angle. So the answer is 1 over sine 4. So that's the equivalent. So that's how we use quadrant. Now let's move to special angle, so that like tan 60 is a special angle, so that we get the actual value without the use of calculator. So let's move to special angle. So these are the special angles. But now there are also special angles that are not here, like 120. 120 and 60 they are the same thing. So that's why we didn't bother to add it to the table. So there's how for over years now, how I memorized this when I was still in high school. That's senior secondary 1. So see how I do it. The sine of any angle is between minus 1 and 1. So the maximum is 1, which is this 90. So for now, we'll know from 0 to 90, yes, with a pattern. So starting from 0. So sine 0 is 0 to 90, the maximum is 1. Yes. Why others will have denominator of 2. So why the numerator will start from 1 with 2, and with 3. So once we're able to know these, others will be simple, yes. Once we are able to know these 5, others will be very simple. You'll be surprised. Okay, let's do it. From our cofunction identity, sine 0 and cos 90 are the same. Yes. Do you remember? From our cofunction identity, sine x is cos 90 minus x. So sine 0 is now cos 90 minus 0, which is cos 90. So sine 0 and cos 90 will be the same thing, which is 0. 60 and 30 will be the same thing. So y 90 and 0 will be the same thing. You see? So it's just the same thing. The opposite from the back now. You decrease from the 3 as the numerator with 2 and 1. So that is it. Now, from our quotient identity, do you remember that tan is sine over cos? Yes. So remember that tan is always sine over cos. So now 0 over 1 is 0. 1 over 2 divided by root 3 over 2 will now be 1 over 3. But you rationalize to be root 3 over 1. Why? This and this are the same. So if you divide the same thing, giving us 1. So y root 3 over 2 divided by half is root 3 over 1, which is root 3. 1 divided by 0 is undefined. Yes. So it's undefined. Let's use undefined. Because we know division by 0 is not defined in mathematics. 0 denominator is 0. So it's undefined. So do you see how we fill up this? Let's now complete it. We now move to quadrants. 180, second quadrant, third quadrant, fourth quadrant. So we know that in second quadrant, the angle, we now use actual angle to use is now 180 minus the given. Now 180 happens to be the given angle, so it's now 0. 180 minus 180 is 0. So the equivalent is 0. But remember, it's only sine that is positive. Cos and tan that are negative. So this is equivalent to sine 0, and sine 0 already is 0. Why this is equivalent to minus cos 0? Yes, because second quadrant cosine is negative. So 180 minus 180 is 0. So it's now minus cos 0. And cos 0 is already 1, so minus 1. Y 0 divided by minus 1 is 0. 270. The equivalent will be 90, yes. Because the given angle is 270. 270 minus 180, that's third quadrant. 270 minus 180, see it. It's now 90. So the equivalent is 90. So 270 is equivalent to 90. But remember, it's only tan that is positive. So this is now minus sine 90. And we've gotten sine 90 as 1, so minus 1. Why this is minus cos 90? Cos 90 is already 0, so minus 0 still be 0. So minus 1 divided by 0, also division by 0 is undefined. So y 360, the equivalent is also 0, yes, because the given angle is 360. So 360 minus 360 is 0. So it's now, remember, it's only cosine that is positive. So this is 1. This is now cos 0, which is also, why this is minus sine 0, because sine 0 is already 0, so minus 0 is 0. So 0 divided by 1 is 0. So no need, I made the table for only the first three functions here, because others are reciprocal of these 3. So that's why I didn't bother to add the other 3. So that's how I still remember it till today. So now, let's solve a equation that will help. We'll now get the actual value. Okay. Now I want to apply the use of that table of special one. So we have to evaluate the following without a calculator. So the first one, so we have sec 210. You know that sec is 1 over cos. Yes. And the 210 is in which quadrant? Third quadrant. And we normally subtract the given angle. We subtract 180 from the given angle. So 110 minus 180. And it's only tan and cot are positive. So it's now minus cot. So now I have 1 over minus cos. 210 minus 180 is 30. So it's now minus cos 30. 1 over minus cos 30. And we have cos 30. We know from the table is 3 over 2. Yes. We check. So we need to the 3 over 2. So the answer is now minus 2 over 3. Or you might decide to rationalize, multiplying by the conjugate, which is 3. So it's now minus 2, 3. That's multiplying both numerator and denominator, right? By 3. So that's the answer. That's rationalize. It's either this or this, anyone. So the second one, cot 300. So again, 300 is in which quadrant? Fourth quadrant. So we'll start with that cot. Cot is 1 over tan. And since it's in fourth quadrant, tan is negative there. And the conversion factor we use, the angle will be subtracted from 360 minus 3. Yes, from the table. From the special and see from the quadrant 360 minus given. So the given angle is 300. So you have 1 over minus tan 60. Now what is tan 60? 3. Yes. So you can decide to rationalize. So the answer multiplying by root 3 or up and down, that's numerator and denominator. That's the answer is minus. So anyone with this. So this the C part we have to do through cosec. Cosecant 150. So I will have cosec 150. But remember, cosec, we should remember that cosec is 1 over sine. So 50 that equals, since we are in second quadrant, sine is still positive then. So now do 180 minus 50. Yes, remember, from the quadrant, second quadrant, the 180 will subtract the given angle. The given angle is 1/5. So now have 1 over sine 30. And sine 30 is half. So 1 over 2 is. So why the last question? The last question, cos 120. So again, that's cos 120. 120 is in which quadrant? Second quadrant. So cos is negative there, so I have minus. And you subtract 120 from 180. So that's minus cos 60. And cos 60 from the table is half. Yes. Remember, you need to memorize this, or you won't have access to the table. So just remember the way I treated it, how what I use in filling on the method I use. So just remember it's easy to answer. So we are done with this question. So look at this one. We're moving to another question. They said if triangle Okay. So if triangle ABC, that's ABC is a triangle, tan A is K, then tan B plus C is dash. Okay. This question is still simple, yes. Since if ABC, okay, let me just write that. We have triangle ABC. So these are the angles. Angle A, angle B, and angle C. So everybody here knows that the sum of angles in a triangle is always 1/8. So if you add A, B, and C, angle A, B, and C to be 1/8. So if we now make B plus C the subject of formula here, now I have 180 minus 8. Yes. So now let's move to the equation. Therefore, we're asked to find tan B plus C, which is the same as tan 180 minus 8, as we've proved here. We've shown it since the triangle. Now, this is now a second quadrant angle, yes. And remember, in second quadrant, tan is negative, so this tan minus tan A, yes. Yes. Because in second quadrant, tan is always negative. So, answer is now minus. What is A? Tan A is K. So the answer is minus K. So it's still simple, but tricky. That's option A. So why the second one? We ask which of the following is equal to tan 270 plus x. We can still solve this without a calculator, yes, without trial and error. So how do I do it? Okay. I'll just So I can write, see how I solve this. I can write 270 plus x as 360 minus 90 minus x. So let's check. Open up. 360 minus 90 is 270. Minus times minus is plus. We are still correct. Yes. Now, you can see this is now a fourth quadrant angle. 360 minus. And tan is negative there. So this is just minus tan 90 plus x. Sorry, minus x. What is in the bracket? Yes, from our quadrants. From the quadrants, the actual angle is 360 minus the given, and tan is negative. So it's only sec and cos are positive. Others are negative. So let's go back to this position. So this is the same as minus tan 90 minus x. Yes. So the angle here, you see the actual angle, you see the given angle, not the actual angle, just anyone it could be. So since it's 360 minus, so the given angle is now 90 minus x. So minus negative because tan is negative there. So what do you observe? You can still continue. You can see that tan 90 from cofunction identity, tan 90 minus x is cos. Yes. From our cofunction identity, yes. From the cofunction identity, always remember this. I won't be going back. Always remember cofunction identity. Very important. See it. Tan 90 minus theta is cos theta. So, We are still on the right track. So no need of testing with, I know some students will test to know which one by using values. No, the actual solution is this. Though you can still use advanced, that's an advanced trick, but with this simple, using quadrant is still correct. And cut is 1/10. So our answer is done. So that's the complete answer. So which of them you now see is option C. Perfect answer. So I used quadrant to solve it. That's options. So let's look at this one. We said if sec squared x plus tan squared x is 3, then the angle is dash. Okay. First of all, sec and tan are related, yes, from our Pythagorean identity. 1 plus tan squared is sec squared, yes. So I can replace sec squared now, the actual solving, the actual solution. Sec squared now I can replace it with 1 plus tan squared. So before adding the tan squared, this is equal to 3. Now we can add tan squared and tan squared, which is now 2 tan squared, which is equal to 3. So subtracting 1 from both sides, we see that we're left with 2. 3 minus 1 is 2. Dividing both sides by 2, we have 1. And moving square to the other side becomes square root of. And square root of 1 is plus or minus. So plus or minus 1. Yes. There's a reason for the negative angle because tan is in some quadrant is positive, while in some is negative. So careful. So now it has two answers. So the value x is now the arctan of plus or minus 1. Yes. So it's to have both all the quadrants and angle. Yes, because it's positive in first. Tan is positive in first and third. Yes. Y negative in second and fourth. So the answer is now equal to, for tan to be positive in first quadrant is 45 degrees, yes. Which quadrant again? Third quadrant, which is 225, yes. So which quadrant again is in negative? It's negative in second quadrant, so which is now 180 minus 45, which is 135. So, and the fourth quadrant, 360 minus 45, we now have 350. So that's it. So these are the complete answer. The first two for positive, while the last two is for negative. So which of them is that? Okay, we have P. So the answer is option B. We have only one answer. So that's option. That's option B. So let's move to the other question. We asked to solve this equation. But first of all, if you look at the range of x is in radian. So you should know that in trig radian, that's pi is equal to 180 degrees. So that's it. So this is just 90. It's less than x and it's less than or equal to 360 degrees. So in trig, pi means 180 degrees. So let's solve. So first of all, let's move everything to the left hand side. So I move -1 to the +1 equal to 0. So To make it easy, just let sine x be y. Yes. So we now have 2y squared minus 3y plus 1 equal to 0. So this is a quadratic equation, and we'll first factor the left hand side as 2y minus 1 times y minus 1 equal to 0. And for the product of two numbers to be 0, one of them must be 0. So it's either the first one is 0 or the second one is 0. So y is now half, or y is 1. So remember, we're not asked to find y, we're asked to find x. So we'll go back to the so when y is half, we now see that sine x is half. So it implies that x is now arcsine of half. So, which is 30 degrees, and 30 degrees means pi over 6. That's 30 degrees. Remember, pi is 1/8. So the options are in radian. So, and also 1/5, yes, 150. To have 4 answers, 2 in positive and 2 are positive. To have 2 answers, yes, since half is positive. So first and fourth quadrants, first and second quadrant, not fourth quadrant, which is 150. 150 means 5 pi over 6. Since pi over 6 is 30, 5 times 30 is 150. So that is it for when y is 1, we now see that sine x is equal to 1, which implies that x is now arcsine of 1. So 90 is pi over 2, and where again, second quadrant, 159. So that's the only answer. So the answers are pi over 6, pi over 6, and pi over 2. But they gave us this condition. Look at what is given. They said the angle is between 90 and 3/6. Yes. And 90 is not even included. The 90, so this is off. Since they included first quadrant, which is pi over 6/3, so it's off. So the best answer is T. It's only this one that made us that pi over 2. Okay, pi over 2 and pi over 6 are off. So it's only 5 pi over 6 is the correct answer. That obeys this range. So that's it.
So we're asked to solve the equation 2 cos squared theta plus sine theta equal to 1. So theta runs from 0 to 3/6. So we have more than one answer here. So let's solve. We first use what we call Pythagorean identity, yes. Because I'm seeing cos squared, I'm seeing sine theta. So if you could remember, there is an identity that sine squared theta plus cos squared theta is 1, yes. So I can make cos squared theta the subject of formula, which is 1 minus sine squared. So this is called Pythagorean identity. This is called Pythagorean identity. There are 3 in number. So from here, wherever I see cos squared, I call it 1 minus sine squared plus sine theta equal to 1. So we open up 2 times 1, 2, minus 2 sine square theta plus sine theta equal to 1. So if I move this to the other side, it becomes positive. Move that, becomes negative. Move 2 to that side, so 1 minus 2 is minus 1. We are left with 0 on the left hand side. And looking at this is a quadratic equation, yes. Okay, let's say let sine theta be x. So this is 2x squared minus x minus 1 equal to 0. And we can factor this as 2x plus 1 times x minus 1. Yes, equal to 0. I know for two ants, the product to be 0, any of them could be 0. So either the first one is 0 or the second number is 0. So from here we see that x, making x the subject of formula here, we have is minus 1 over 2. And here we have it as 1. But we are not asked to find x, we are asked to find theta. So from here, you see that sine theta is minus half and sine theta is 1. So x is minus half or 1. So from here you see that theta is arc sine of minus half. And here is arc sine of 1. So which of the angle that the sine is minus half? So this negative shows that this must be in third and fourth quadrant. Since sine inverse of half is 30, in third quadrant it should be 180 plus 30, which is 210. And also third quadrant, which is 360 minus 30, which is 330. So theta here gave us two answers, 210 and 330. Y here is 90. Therefore, the answers are 90, 210, and 330. So that these are the answers. Thank you.
We're asked evaluate the product of tan 30, 31, 32 till tan 59 without a calculator. Looking at the question, it looks funny that how can we solve this without a calculator? But you can do that. Okay, we know from our reciprocal identity tan s is also 1 over cot x. Yes, tan x is 1 over cot x, since cot x is 1 over tan x. And cot, from our cofunction identity, cot x is the same as tan 90 minus x. Yes. So what do you have to say? Which implies that if you multiply tan x and tan 90 minus x, it gives us 1. Yes, you cross multiply. So this is a powerful identity to use. Yes. So we'll be using this to solve the equation. So let's look at what is happening in the product. We started from 30, tan 30 times that. You will notice that if I add 31 and 59, it will give me 90. 32 and 58, it will also give me 90. The next one is 33, while here will be 57. They always sum to 90, so I can use this identity. So I'm saying that tan 31 times tan, multiplication is commutative, so I can decide to multiply tan 31 and tan 59. After I multiply tan, that's their product, will multiply tan 32, the product of tan 32 and tan 58. So what do you have to say is 1? Yes, because 59 is the same thing as 90 minus 31. Are you seeing it? And also, if you look at tan 32 times tan 58,
you still get 1. So automatically from here down, from 31 to the product to 59, the answer is 1. Yes, therefore this product is just tan 30 times 1. Yes, because if you pair, it will give us 1 1 1 1. So the product of 1 1 1 1 will also give us 1. So our answer is tan 30 degrees, which is root 3 over 3. That's fast. Option B. So this is just based on this formula, that tan x times tan 90 minus x is always equal to 1. So that's what made us to solve it fast without a calculator. So thank you.
Okay, we ask if log cos x in base sine x is half and the angle x is between 180 and 360. So we're asked to find sine x. Okay. So let's solve. So this will combine a lot to relate to quadratic or something. What I'm saying. Okay. So first of all, we'll need to remove the log function there. So if I move log to the other side, it becomes indices. Yes, that's the inverse. So it's now sine x raised to power 1. Yes. So that's the first thing. Let me just write the original stuff. We have log cos x in base sine x is equal to 1. So first of all, I remove the log by moving the sign to the other side, becomes indices. And now squaring both sides so that it will remove the half as the reciprocals. Now, again, you can decide to, okay, let's just move sine to the other side, comes minus. So from our Pythagorean identity, cos squared is 1 minus sine squared. Yes. So minus sine x equal to 0. From Pythagorean identity, from sine squared plus cos squared is equal to 1. So now, okay. So I can move the other side to the sine square, moving or multiplying both sides by negative. So this is now positive sine x minus 1 equal to 0. So either you multiply both sides by minus 1 or you move to the right so that it will be positive. So now we have a quadratic equation, yes. Because I'm saying sine squared and sine x, so it's a quadratic equation. So using quadratic formula, yes, if you could remember that if you are given as squared plus bs plus c equal to z, x is now minus b plus or minus this. But that's quadratic formula. So that's what I'm going to use here. So I have sine x, my x is now sine x equals minus, my b is the coefficient of sine x, which is minus 1, plus or minus square root of minus 1, or b squared, not minus 1, or 1 squared. So 1 squared minus 4 times 1, a is 1, and c is minus 1, over 2 times 1. So I have sine x equals minus 1 plus or minus, it's 5, this is 4, 4 plus 1 is 5, over 2. Okay, looking at the answer, we need to be careful here. we need to be careful. Remember, sine of any angle is between 1 and -1. The minimum is -1, the maximum is 1. Yes. So the sine of any angle is between -1 and 1. So we need to consider this. And root 5 is -2 point something. So if I add -1, I'm taking the negative first. -1 minus root 5 will be -3 point something. And if you now do -3 point something divided by 2, it will give you -1 point something. Yes. And -1 point something has exceeded the boundary. It's not on this. So the negative is off. So let's consider the positive. -1 plus 5. I told you 5 is 2 point something. So if we now do -1 plus 2 point something, it will give you -1 point something, yes. And that -1 point something divided by 2 will now give you -0 point something. You get it? And it's within this range. So the answer is -1 plus 5. Right, so the actual answer is option A. Yes. So don't make mistake. The answer is option A. That's option A. Okay. We're on negative identity. Yes, it's possible. Remember, we move clockwise, counterclockwise, but we can decide to move clockwise. So, but we won't go deep. Just summarize the identity or formula. So you should know that, and I've told you, once you know the first three trig functions, you've known the last three. So the negative identity, the first one is that sine negative theta, yes. So it's the same as minus sine theta, yes. Why the second one, cos negative theta, is just the same, neglect the negative sign, yes. The last one is tan negative theta is negative tan theta. So that's the negative identity. No need of writing the other three. So we normally call the first one sine negative and tan negative. They are called odd functions. We won't go deep on that, just knowing. So these are odd functions. While cos is an even function. I just know it. But let's look at this question. Evaluate the following. Okay, let's move to another page. So right to read. Okay. Now we're asked to find sec minus 2/4. Okay. So the first thing, sec is 1 over cos. So sec negative 2/4 is 1 over cos negative 2/4. Yes. Or reciprocal identity. And now cos, I told you, is an even function, so just neglect the negative sign. So we now move to the third quadrant. 2/4 is in third quadrant. And remember, we always subtract 180 from the given and done it. And cosine is negative in third quadrant. It's only tan and cot. So I now have 1 over negative cos 60. And cos 60 is half, so I have 1 over negative half. So the answer is negative 2. So that's the final answer. Why the second question? We have cot 330. So first, we know that cot is 1 over tan. So this is cot negative 330 will be 1 over tan negative 3/10. Now, from our negative identity, we bring out the negative sign. So negative tan 330. And 330 is in which quadrant? Fourth quadrant. So we subtract 360. We subtract the angle from 360. And since tan is negative there, so we have negatives only. It's only cos and sec. So this negative sign is that's the result of the fourth quadrant, remember? So that we won't make mistake. We have two negative signs there. So don't make mistake. See, it's only cos and sec are positive, tan and others are negative. So don't. So this for this thing, before we now put the negative sign, the one we brought out. So this one now is for this. Why this negative as a result of the quadrant? So negative times negative is positive. So I have tan 360 minus that is 30. And since we've gotten the value, tan 30 is 1 over root 3. Yes. So the answer is root 3. 1 over root 3, which is root 3. So the last one is cosec. Cosec minus 150. Cosec minus 150. So first know that cosec is 1 over sine. So it's now 1 over sine minus 150. Again, remember from our negative identity, we bring out the negative sign. And since 150 is in second quadrant, sign is always positive. So it's always positive. But remember this sign. The former sign, the one we brought out, we put it, and we subtract it from 1/8. Yes. So we now have 1 over minus sine 30. And sine 30 is half. So I have 1 over minus 1 over 2. So the answer is minus 2. So this is for negative identity. So we're on periodic identity, yes. So have you thought of higher angles? Yes, because if you notice what we've done, they're within 0 to 360 degrees, but they can still ask you something that exceeds 360. So periodic, remember we have a circle in the quadrants. The quadrant is like a circle. 360, maximum is 360, but you can still go around. For example, in athletics, if you are to run 800 meters, since the track is complete track is 400 meters, so we are running 2 times, starting from the finishing line, you go 2 times. So that's if the angle is now higher, we'll keep on moving around. So meaning for sine and cosine, for sine, the reciprocal, cosine and its reciprocal, the period is 360. But for tan and cot, the period is 1/8. So let's look at this identity. The first one, remember, I'm going to write only 3, the remaining 3. is the reciprocal of the first three. So if you have sine something higher than 360, that's 360 degrees k times k. Yes, is equal to sine theta. Yes, where k is an integer, mostly positive integer. So y for cos is the same, cos theta plus 360k is always cos theta, but for tan is 180k. So the answer is tan. So it's just higher angle. But if you notice this theta, if you add it to 360 times an integer, do you get? So for it to be within the ones we've been solving, k will be 0. So when k is now larger than 0, integer like 1, 2, 3. So let's look at this question so that you see what is happening. We're asked to evaluate this. Okay, remember, we still have negative angle here. So we use our negative identity. The first one, sec minus 160. Sec is 1 over cos. So cos minus 160, 1860 degrees. And remember, cosine is an even function, so neglect the negative sign. So now, this is where we apply the periodic identity. So we now check how many 360 are here. We have 1860. How many 360 will be there? So that's it. So how many 360? Remember, we're not using calculator. So if I multiply 360 by 10, I have 3000. Okay, let's make it multiplying by 5. I have 1800. You see? So meaning I can write this as cos 60 degrees plus 360 times 5 using our Pythagorean, using our periodic identity. You see, using this, I've splitted the larger angle to be theta plus 360 times k, 360 degrees times k. So that's the advantage of this periodic identity. So this is just equivalent to cos 60. And cos 60 is half, so 1 over 5 is 2. So if you use your calculator, that's exactly what you get. So let's look at the second one, which is cos minus 1110 degrees. So first, we know that cot is 1 over tan. So we now have 1 over tan minus 1110. Now remember, tan is an odd function. We need to bring out the negative sign. So now I have 1110. So now how many 180 from what we've done? We're using the periodic identity now. How many 180 is here? So let's guess. If I multiply by 10, it will be 1800. So if we try, let's try 6. So this 8 carry 4, 1080. So if I do 1110 minus 1080, let's see how many is left. This is 0. This is 11, and that's 3. So that's okay. So now we can partition this as what? Is now 30 plus 180 times 6 using our periodic identity. So this is just and that, yes, and tan 30 is 1 over root 3. So the answer is minus root 3. So do you see we are solving without a calculator? So even if you use your calculator, you still get the same answer. So the last one, we have cosec 3. So we have cosec minus 3285. So I told you cosec is 1 over sine, so mine is now sine minus 3285. Also, sine is an odd function, so we'll bring out the negative side. So negative sine 3285. So this is now minus 1 over. Now let's check how many 360 will be there. So if I multiply by 10, I have 3600. So which has exceeded this. Let's check 9. 36 times 10 is 3006. So I'll have 3285. So let's check. If I do 360 times 9, so this is 04, carry 5, that's 10, 75, that's 32, yes, 3240. So how many is remaining? So if you have 3285 minus 3240, let's say 5, okay, it's 85, so we're left with 45. So this could be written as minus sine 45 plus 360 times minus 9. So this is just minus 1 over sine 45. Now for sine 45 is 1 over root 2, so we have minus root 2. So minus 1 over root 2 is minus root 2. So that's the answer. That's how we use. Welcome back. We'll look at graph of trigonometric functions. As before now, we've known that we have 6 trig functions. And now we're going to look at the graph, how to sketch the graph. And what will help us to sketch the graph is this table of special angle. Yes. In our former class, we did this as the table. Okay, look at the table of special angle. So it will help us to sketch the 6 trig functions. So let's look at the first one. So the first one is sine, yes. I had to use an app so that it will be very neat. So if you notice, the graph is always like this. Graph of y equal to sine x is always like that. So let's label so that so we see that the maximum, if you say from the table, the graph is always between -1. The minimum is -1 and the maximum is 1. So just know that the graph of sine is between 1 and -1. Very important. Because we're going to solve this. We're going to solve a question under this thing. It's a simple version after the graphs. So you should know that the minimum is -1. So to alternate between -1. So that's the maximum. So what gave us that maximum? 1, which is 90. It's 90 degrees that gave us, while the minimum is 270. So here the value, the x value is 270 degrees, while here is 90 degrees. So you can see 0, sine 0 is always 0, so that you see, so here is the point 0. So why here sine 1/8 is also 0. Y 3/6 is also 0. So these are the most important points on this graph. This 1, 2, 3, 4, 5. So we've sketched the graph. So the graph is always like this. So let's look at cosine. So using that same table, you see that the maximum, the graph of cosine is between, alternating between -1 and 1. So it's between -1 and 1, check. You see maximum is 1, minimum is -1. So if we sketch the graph, so the maximum here, cos 0 is always 1. So here is 0. From the table, you can see that y cos 90 is 0. So here should be 0. Also 270, 0. As you can see. And 360 is 1. So here should be 360. If you trace them. So y here is 1/8. 1/8 is -1. So it's here is -1. So these are the most important points on this graph. So we'll sketch that. So coming to the next one, which is tan. So see the graph of tan. If you notice, there is a discontinuity in some places. Yes. So if you could remember, tan 90 and 270, they are undefined. Do you remember? Yes. So, and in one undefined in graph, it's called a vertical asymptote. Yes. It's not defined, so there will be gap there. So if I put this line is called a vertical asymptote. So there will be a vertical asymptote at 90 degrees and 270. So we call this vertical asymptote. So y here, if you could remember, 0 times 0 is 0. So here is 0. That's here. And 0 is 0. Also here, see that 1/8 and 1/8 is still 0. and 3/6 0. So tan has no maximum and minimum. As you can see, it can increase to any point. So the major point we are going to note here is the where it is not defined, which is the vertical asymptotes. So that's the graph of tan. So let's now move to the other, because from the table we have only 3. Let's use the knowledge of these 3 to plot the other ones. Yes. So how do you plot, especially sec and cosec? So once I've plotted the graph of tan, once I've plotted the graph of sine and cos, we can plot the graph of sec and cosec. Yes. So how do you do it? Let me just sketch before we move to the actual graph. Let's just sketch. So remember that the graph of sine, just sketch. We'll use that later. If you sketch the graph of sine, it's always this way. Y here is minus, this is minus 1, sorry, this is 1, this is minus 1, and this 3, this is 90, that's 90, here is 90, Y here is 270, this is 0, 180, and 360. So, remember the values from the table, since cosec is the reciprocal of sine. And there are some places where sine is 0, sine of the angle is 0. So there will be a vertical asymptote at 180, because 1 over 0 is undefined. So anything over 0. So there will be a vertical asymptote at 0, 180, and 360. Yes. So if we now draw the vertical asymptotes here, and here, okay, this is already nice. So since we are talking about reciprocal, and flip this the other way around. So the resulting graph, remember this graph, this one is y equal to sine. So the red one is now cosec, y equal to cosec x, yes. So that's how we sketch the graph of cosec. So once you've drawn the graph of sine, you now get your vertical asymptotes. Remember, the green line is the vertical where it's not defined. That's where division by 0 occurs. Asymptotes. So once you get it, the other one, the resulting graph, by flipping the other one, this one is concave down, make it concave up. The same thing the other way around. So that's the graph of cosec. So let's make it neat. You see, so here is 0, this is 180, where it's not defined, and this is 360. Why here, the maximum, that's the minimum here, this is 270, cos at minus 1. Why here? Right, so this one. So that's the graph. This is the vertical asymptotes. That's the graph of cosec. So that same logic, we can use it for or sec, yes. Since we know that the graph of sec cos is like this. It's always like this. So where here is the maximum 1, while here is minimum -1. And it occurs where? It occurs at 90, 0, here, 0. So the 0 is 1. So this is 362. This is 270. This is 18. So the same way, if we now get our vertical asymptote, so it will be on the, if you reciprocate, so since sec is 1 over cos, so meaning there, and we know that there are some places cos is 0, which is at 90 and 270. So if we draw our vertical asymptotes there, so we now flip the graph the other way around. So the same way, almost the same. Flipping it. See the other way, why this is. So why this is. So since this one, this is y dot plus. The red one is now sec. The red graph is now y dot sec. So that's how we sketch the graph of sec using cosine. So let's now use let's use nits. You can see what it looks like. Like I've said before, this is 1, that's -1. And the vertical asymptote occurs at 90. Was at 90 and 270. So here is 180. That's where is negative. So why this is 360? So each time you want to plot once you were able to plot the graph of sine, you can get the graph of y for cot. Again, tan, the graph is this. So meaning, where is 0? So for cot now, the vertical asymptote to occur. Okay, let me just sketch before. So let's sketch the way we sketched. Let's draw the tan first, then we'll sketch. So tan is always this. There is a vertical asymptote that's 90 and 270. You know, at 0, that's this 0 is 90. This is 180 is also 0. This is also 0. 270 is vertical asymptote. So it will go this way. So that's how it will look like. Now, the reciprocal, so where is 0 now? Is 0 at 0, 1, 8, so there will be a vertical asymptote. So the other way around. to be a vertical asymptote. So see how it will look like for what? Yes. Since at 0, okay, this is cut. That's cut. So at 0, there is a vertical asymptote. So where is tan not defined? It's not. Where is 0? Sorry. So 1 over 0, we know that chords but x is 1 over tan x, and it is 0. Tan is 0 at 0. We again 180 3C. So there will be a vertical asymptote. That's 180. What's 3/6? So this is where sine 1 over, since tan 0 is 0, so it will be vertical asymptote at this basis. Why the other way around? This is now 90. Where it is not defined now. If you reciprocate, remember undefined means division by 0. So if you now reciprocate, where is 0, it will be defined, it will be 0. You get? If you reciprocate undefined, it's now 0. So that's why it's 90. If you check, tan is undefined. At vertical, still the other way around now. For cut, it will be 0. So y here is 2/7. Where there is a vertical asymptote at tan, it will be 0 at cut. So that's how we sketch the graph of 3 functions. So let's
First of all, we should know that the sine of any angle must be between 1 and -1. Yes. So the minimum is -1, maximum. So for this to be maximum, this should be positive. So making this to be negative, yes. Because if it's positive, the answer is negative. So we are saying that therefore sine 5 theta minus 10 degrees should be equal to -1, yes, which is sine 2/7. And from here we see that 5 theta will be 280 degrees, yes, making it the subject of formula. Therefore theta is 56. So that's the answer, option A. So thank you. First of all, we know that the cosine of any angle must be between -1 and 1. And also, for a fraction to be minimum, we should make the denominator very large, yes, while the numerator small. So what am I trying to say? So our concentration lies here. So we should use the maximum value of cosine, which is 1. So our answer is 12/3, which is 4. So option B. So that's the idea we use here. Thank you. Okay, welcome. We are given this table and we're asked to complete the table. Draw the graph of y equal to sine 2x and y equal to cos x. Use the graph to solve cos x minus sine 2x equal to 0. So the first thing we have to do is to complete the table, because if you are given a table of value, before we plot the graph, we need to complete the table. And how do you do it? We keep on substituting the values of x and y. So like I'll just do one. I will paste the complete table to save time. So example,
7.
Like for the first table, when x is 30 degrees, you see that for y equal to sine 2 times 30, we have sine 60. And sine 60 is 0.8660, which is 0.9. We'll be using one decimal place. So that's the same way. If you now substitute y equal to cos 30, cos 30 and sine 60 are the same, so we have 0.9. So that's how we fill up the tables. So for the second one, okay, we'll fill for 150, we have sine, when x equal to 150, we have y equal to sine 2 times 150, which is sine 300. We know sine 300 is in fourth quadrant, which is minus sine 60. So we have minus 0.9. So for cos, y equal to cos 150, which is the same as minus cos 30, which is minus 0.9. So that's how we do and fill up the table. So no need of wasting time. Let me paste the complete table. We now move to graph. So that's our complete table. And from this table, you notice that, remember, we have two graphs here. That's the two values of y. So before we plot the graph, we need to know the maximum and the minimum. So to know that's the boundary for the graph. So from this, x is settled because s is the same in both. So we see that the y minimum is, from the table, is minus 1. And y maximum is 1. So with that, we've known that our graph will not exceed minus 1 and 1. So the maximum is 1 for y-axis and the minimum is minus 1. And for x, we have no negative values, so they are all positive values. So this will help us to locate the origin. So that's the essence of knowing the minimum and maximum. So we are getting our axis. So let me place this for x, for y. So we are getting our x and y axis. Okay. So as you can see, I think the origin will be better here. Let's check. If I count 1, 2, 3, 4. 1, 2, 3, 4. So the origin, the best place to locate the origin is here. So our origin is here. That's 0. Y, our x-axis. So that's our x-axis. Another name for x-axis is y equal to 0. Why this is y-axis, or x equal to 0. So we've located the origin, we've located the y and the x-axis. Let's now locate that's the maximum. Let's put the points. So this is, if I count 1, 2, 3. 1, 2, 3, 4. So this is my 1. Meaning here is 0.5. This is minus 0.5. This is minus 1. Yx, we are moving in intervals of 30, so we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. So we've located that's the table for x, as the values of x and the values of y. So let's now locate the points. So here, when x is 0, y is 0. I'll plot the first one and join before plotting the second one, so that won't make mistake. So when x is 0 for the first one, now let me just copy and paste the table where it will be. You will see it. Let's copy and paste. Okay. When x is 0, y is 0. So this is the origin. Let's use so that's it. That's the first point. When x is 30, y is 0.9, and we didn't get something here. Let's try. Remember, to get each of these grid line, we need to calculate it. Yes, each of these small minor grid lines. We've known the major one. We are going 0. Let's get each of them. And how do you do it? Each grid line for y is the interval we are moving over the total grid line to that interval. So we are moving in interval of, because the scale here, the scale is either 2 cm to 0.5 units. So the interval is 0.5. We are moving in 0.5 over the total grid line to that 0.5 is 10. So each of these will be 0.05. Yes. So each of these grid line is 0.05. So to locate a particular interval, that's the total, any total grid line now, then y will be interval over each of the grid line. So meaning that the values of y, each time I'm looking for it, if it's not seen visibly, I would divide that value by 0.05. That's it. Like if I want to locate 0.9 over 0.05, that gives me the total grid line. To get 0.9, I have to do 0.9 divided by 0.05 so that I can locate the total grid line starting from the origin. So if I do 0.9 divided by 0.05, I have 18. So I'll move up to 18. So we'll count. When x is 30, I'll move 18 grid lines up. So 5, 10, 15, 16, 17, 18. So that's my 0.9. So, and again, this is 60 is also 0.9. So is here. So in order to, okay, for 90 is 0, see 90 0. For 120 minus 0.9. So since 18 up is positive, 18 down will be negative. So 5, 10, 15, 5, 10, 15, 16, 17, 18. So for 180 For 150 is also that, so this is that. For 180 is 0, that's it. For 210 is 0.9, that's positive. We'll go up 1, 2, 3. For 240, that's same positive, that's 1, 2, 3. For 270 is 0, so we'll go down 0. For 300 is minus 0.9, so we'll go down 18 times. 1, 2, 3. For 330 is the same, negative 0.9. 1, 2, 3. For 360 is 0. So we join. We'll take different ink. Okay, let's take green. So we're joining the point. That's it. That's it. We are moving. That's it. 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 And finally, so that's it. Let's change the color to green and let's make the line tick. So that's the first graph. We've done y equal to sine 2x. So let's label it. This is y equal to sine 2x. So let's draw for y equal to cos x. So we'll locate the points. Let's use blue. So when x is 0, y is 1, so 1. See, x is 0, y is 1. So that's the point. When it is 30, 0.9, so the same point as that. When it is 60, is 0.5, so 60, 0.5. That's the point. When it is 90, we have 0. That same point. When it is 120, you have minus 0.5. So 120 minus 0.5 is down here. It's visible. When it is 150, we have minus 0.9. So that same point here. When it is 180, we have minus 1. 180 minus 1, so we have this. So when it is 210, we have minus 0.9. 210 minus 0.9. Remember, 0.9 is 18 down here, 5, 10, 15, 16, 17, 18. So that's for 210. When it is 240 minus 0.5, 240 minus 0.5 is here. 270, 0, that's same point. 300, 0.5. 300, 0.5 is up here. 330, 0.9. 330, 0.9 will be up. Let me move this to this side. Just move it after we continue. So when it is 330, we have 0.9. 330. 0.9 is 18 up, 5, 10, 15, 16, 17, 18. And when it is 360, we have 1. So 1 is here. So that's the point. So we'll finally join. Let's join the point. So we don't need this again. We don't need it. So let's join our points. So let's get our curve. So we are joining. We started from this, we'll move to this, we move to this, we move to that, we move to that, the next point, we move to the next point, we move to the next point, we move to that point, we move to that point, we move to that point. We move to that point, we move to that point, and finally to 360. So that's our curve. Maybe let's change the color. Let's change the thickness, and let's change the color. That's okay. So that's our second graph, which is y equal to cos x. Y equal to cos x. So let's label. We have, this is y equal to cos. So the next thing is to use it and solve the next question. They say use the graph and solve. We've done the first part, we've completed the table, we've done the graph. They say use it and solve cos x minus 2x equal to 0. Use the graph and solve cos x minus sine 2x equal to 0. So whenever you're asked to use a graph to solve a particular equation, what you have to do is to transform. So we're going to transform the given equation to look like the plotted function. So if you notice, the graph we plotted y equal to sine 2x and y equal to cos x. So we're going to transform this to look like these two graphs. So let's start. We have cos x minus sine 2x equal to 0. So moving this to the other side, we have cos x equal to sine 2x. And what's the meaning of this? This means the point of intersection maybe we have more than one point, so the points of intersection of the two graph function, that is y equal to cos x and y equal to sine 2x. So that should be the answer. So we'll go over to the graph and locate the point of intersection. So let me locate it. Let's use black. So you notice that they intersected here, so let's call it point A. So that's the solution. The x value, which is 30, that's the solution B. That's the solution, which is C at point C, which is x equals to 150. So we have 2/7, so which is D. So the answer is now the points of intersection of these two graphs, which are 30, 90, 150. So which are 30, 90, 150, and finally 30, 90, 150, and 2/7. So these are the answers. So it's a very tricky question, but it's simple. Thank you.
At the point of intersection, sine x is equal to cos x. Yes, so at A and B, the two graphs are equal. So solving this, dividing both sides by cos, I have sine over cos, which is 1. So this is tan x equal to 1. So x is the arctan of 1. So what's the angle that the tan inverse is 1? So we have two angles. The first is 45 degrees, while the second is 225. Because third quadrant tan is positive. So from here you see that A. So you can see from here A is 45 degrees and B is 225. So you can see from here. So this is 225, this is 40. It's 225. C is now in y. C is the y value, which is cos 45 or sine 45. So it will give us root 2 over 2. YD is also cos 225 or sine 225. So both of them will give us minus root 2 over 2. So from here you can see our answers. A plus B is 225 plus 45, which is 2/7. YC minus D is root 2 over 2 minus root 2 over 2, which is root 2 over 2 plus root 2 over 2, which is root 2. So that's the answer. Thank you. Welcome back. We're on horizontal shifting of sine graph. It's possible you might be given a graph of a sine function and you're asked to find the function, the exact function. So the function will be within these 4 graphs. So the parent graph is the blue one. So this is a sine graph because it starts from the origin. Y cosine starts from the y-axis, that's the intercept, y-intercept. So this is y equal to a sine kx. So we can get the other 3 by shifting this blue graph either left or right. And also reflect it about the x-axis. So look at this, y. This one in blue. Look at the red one. So if here is A, because here A, the absolute A, is called the amplitude. So if here is A, here is minus A. So this graph, the graph of the red function, so this one will be y equal to, as you can see, is now y equal to minus A sine kx. So do you see it? If you multiply by minus, you get the red graph. Again, we've gotten the two, this blue and red, remaining the other one. So if I decide to shift the blue graph to B units, so this graph, the equation will be y equals A sine k bracket x minus b. Yes. So, but if I shift it to the left, b unit, that's here is now minus b. This graph, this one will be y equal to A sine k bracket x plus b. So, and again, there's what we call the period. The period is the distance or the time, that's from here. So you notice that this graph started from this and ends here. So it will still continue. So this is the end point. This is called one period. So from here to here is called a period. And it will represent it by, is denoted by t. And one period, t, is always 2 pi over k. And remember, k, where k must be a number greater than 0. K must be a positive number. Or if it's a negative number, we use a property. That's odd function property, that's sine negative k is now minus sine k. So we use that property. And also, since this is the one complete period is 2 pi over k. So I'm saying that here is 2 pi over k. Why this one? Remember, we shifted this one b unit to the right. So the point here will be 2 pi over k plus b. So that will be the one that it will end here. It started from B and it will end here. Why this one that shifted to the left will be 2 pi over k minus b. So that's it. So let's look at this question. So we're asked which of the following is the graph given. So we're asked which of the following is the graph given. So looking at this, you see that this is a sine graph, as you can see. But it's shifted 1 over pi to the right. So this is a sine graph because it started from the origin and shifted. So it's a sine graph. So if you shift back, if you shift 1 over pi to the left, we'll get back to the original. So this graph must be in form of y equals A sine k bracket x minus b. So our main aim is to find A, K, and B. So as you can see, from here our A is settled. So A is 2. That's it. So it's 2. So this is y equal to 2 sine. So let's get k. From here, how do you get k? We need to get the period. If you notice, one complete period is from here to here. To this point. But you got also another period ends here. So what do you notice? T is here, T is here. So we have 2 periods. So this graph covered 2 period, starting from this. So what do you have to say? We calculate it by using the formula that period, remember we say that t is 2 pi over k. So, and we have 2t already. So 2t will be times 2, 4 pi over k. And let's get the value. So this is 1 over pi. Why this is 4 plus 1 over pi? So meaning that from there, this 2 period, that's from here to here, will be 4. Yes, since here is 1 over pi and here is 4 plus 1 over pi, so the gap is 4. So this is equal to 4. So what do you have to say? K is pi, or k is pi. So our answer and our shift, remember we shifted to the right. Yes, the original function will always start from the, but we moved 1 over pi. So our b from here, b is 1 over pi. So let's now write, therefore the graph is now y equal to 2 sine k is pi, x minus b is 1 over pi. So anything like that. Okay, let's open up. So we have 2 sine pi times x is pi x, and pi times 1 over is minus 1. So this is the answer, y equal to 2 sine bracket pi x minus 1. So our answer is option B. So that is how we solve question that involves horizontal shifting of sign graph. Thank you. Welcome back. We're on horizontal shifting of sign graph. It's possible you might be given a graph of a sine function and you're asked to find the function, the exact function. So the function will be within these 4 graphs. So the parent graph is the blue one. So this is a sine graph because it starts from the origin. Y cosine starts from the y-axis, that's the intercept, y-intercept. So this is y equal to a sine kx. So we can get the other 3 by shifting this blue graph either left or right. And also reflect it about the x-axis. So look at this, y. This one in blue. Look at the red one. So if here is a, because here a, the absolute a, is called the amplitude. So if here is a, here is minus a. So this graph, the graph of the red function, so this one will be y equal to, as you can see, is now y equal to minus a sine kx. So do you see it? If you multiply by minus, you get the red graph. Again, we've gotten the 2, this blue and red, remaining the other one. So if I decide to shift the blue graph to b units, so this graph, the equation will be y equals a sine k bracket x minus b. Yes. So, but if I shift it to the left, b unit, that's here is now minus b. This graph, this one will be y equal to a sine k bracket x plus b. So, and again, there's what we call the period. The period is the distance or the time, that's from here So you notice that this graph started from this and ends here. So it will still continue. So this is the end point. This is called one period. So from here to here is called a period. And it will represent it by, is denoted by t. And one period, t, is always 2 pi over k. And remember, k, where k must be a number greater than 0. K must be a positive number. Or if it's a negative number, we use a property. That's odd function property. That's sine negative k is now minus sine k. So we use that property. And also, since this is the one complete period is 2 pi over k. So I'm saying that here is 2 pi over k. Why this one? Remember, we shifted this one b unit to the right. So the point here will be 2 pi over k plus b. So that will be the one that it will end here. It started from b and it will end here. Why this one that shifted to the left will be 2 pi over k minus b. So that's it. So let's look at this question. Okay, we are given this and we're asked to find the graph that is given. So this question requires two theorem or formulas. First of all, because looking at this is a sine graph. As you can see from what I just explained, you see that assuming this started from the origin, you see, assuming we started from the origin, it will go like this. You see, so meaning that the answer A. Remember, I told you the graph of, from what I said, the graph of sine is always y equal to minus a sine k x minus b. So if it is downward, it is minus a, but if it's up, it's plus a, from what I just explained. So the graph of this must be minus a sine, and from here you see that our a, as you can see, our minus a is 2, so we have minus 2 sine. So remaining k. And how do you get k? We get it using our period. So what is the period? As you can see, this graph started from here and it will end here before repeating. Or it will start from here and end here before repeating. So what do you notice? Here is also the period. One period. Or we'll say from here to here is one period. And as I've said, period t is always, I say that t is always 2 pi over k. Yes. And from here, how do you get from here? What's the distance from 0 to pi? So this is pi. Yes, period here is pi. Or if I do 2 pi minus pi. So what do you have to say? Our k is 2. So our k is 2. X minus. Shifting to the right is minus. Shifting to the left is plus. So that's why I have minus. And how many did we shift? Pi over. We shifted pi over 12 units. As you can see. Assuming it were to be the original graph, it will start from 0, or it started from pi over 12. So that's the shift from here to here. That's the phase angle, which is pi over 12. So which of the option? Okay, there is nothing like that, meaning that we need to employ second formula. So let's open up this first. We have minus 2 sine 2x minus pi over 6. So let's check the option to know which one gives us minus 2 sine. And how do you check it? We use what we call addition formula for sine. So there is one formula, addition formula, that says that sine A plus or minus B is always sine A cos B. So okay, I have minus. We'll use minus cos A sine B. So that's the formula we're going to use. The addition formula for sine A plus or minus B is that. So we'll check sine 2x. We are using minus pi over 6. So this is now sine A is 2x and B is pi over 6. We have minus here, so we use minus. So plus for plus, minus for minus. Cos 2x sine pi over 6. So let's check the value. From here, sine 2 cos pi over 6, which is cos 30. Cos 30 is, that is sine 2x times cos 30 is root 3 over 2 minus cos 2x sine 30 is half. So you see that this is equal to root 3 over 2 sine 2x minus half cos 2x. So plugging it back to this, so we have that sine 2x minus pi over 6 is equal to root 3 over 2 sine 2x minus half cos 2x. So factor. If we factor half, I have root 3 sine 2x minus cos 2x. So finally, remember, our main aim is to check if any of them is this. I have minus 2 sine that, so therefore minus 2 sine 2x minus pi over 6 will be equal to minus 2 times half, because we've gotten this as this. So which is this. So we have minus root 3 sine 2x plus cos 2x. So which of them is the answer? So that's the function. Y is equal to, maybe let's write cos 2x minus root 3 sine 2x. Let's check which one is the answer on A. Okay, welcome back. We have 4 different graphs here, but one of them is used in getting the remaining 3. So if you look at this one, the blue one is the parent graph. So there are some features. So we have here A, and we have here minus A. So this A is called, the absolute value of A is called the amplitude. And y, the distance from here to where the graph ends, is called the period. So we normally denote it with T. So P is the period is T. And T is always 2 pi over K, where K must be greater than 0. It must be a positive number. So, and where is K? This is the parent graph. This is Y equal to A cos kx. So the coefficient of x is K. So you notice that to get this second graph, you shift the first one to B units. So if we call here B, so shifting this graph, the equation or the function will be, the graph will be, we now have y equal to a cos k bracket x minus b, because we shifted to the right. But if you shift to the left as this one, also shifting b units, so here it will be minus b. So the graph of this will be, this graph will be y equal to a cos k bracket x plus b. So if you shift to the left is minus b, to the right is plus b. And again, the period here, remember I told you the period is 2 pi, so here is 2 pi over k, meaning that here will be 2 pi over k plus b, since I shifted b units. Why here? If I shift to the left, it will be p, that's the point of intersection here, will be 2 pi over k minus b. So we've gotten the, okay, remaining this last one. The last one, that's the brown one. The equation is y equal to this minus a cos kx. So that's the equation of this last one. As you can see, y is minus because if you multiply by any positive, it becomes negative. So the ones above the x-axis will be below, since it's minus. While the ones below will be above, like this. The values of y here will be positive. So let's now solve the equation to justify that. But before this question, in case if you have k to be negative, so if k is less than 0, remember that cos of negative value is the same thing as the positive, as you neglect it. So we use that property if we notice that k is negative. So let's solve this question. Okay, look at this. As you can see, this graph is a cosine graph, but it's shifted pi over 4. So that's the shift, meaning that this is off, because I have a positive, or is here. But if it started from here, we have the negative. So that's it. So these two are off, remaining these two. Let's check something. I have coefficient of x here, that's k to be negative. So I need to write this as 3 cos. We can bring out this negative 2. This is x plus pi over 2. Well, remember I told you that cosine of negative angle is neglected. That negative side is neglected. So this is now 3 cos 2 bracket x plus pi over 4. Why this is, to bring out the negative sign, I have x minus pi over 2. So which is 3 cos 2 bracket x minus pi. So as you can see, this is shifting to the right. So you see that this is off, but this is left. So it's off. Do you see it? I shifted to the right. So you always be negative. So without even solving further, D is the answer. But let's finish up. Remember, I told you the general function for cosine shifting. Cosine graph is a cos k bracket x minus b. And from here, let's get our k. We don't know the k. We can get the k using the period. From here, you see that the period from, that's this gap from here to here is the period. T is, what's the difference? That's 5 pi over 4 minus pi over 4 is pi. So our period here is pi. But I told you that period T is always 2 pi over k. And from the diagram is equal to pi. So what do you have to say? K is 2. So as you can see, from this, k is 2. So we have A. Our A is 3. Are you seeing it? 3. So I have 3 cos 2 x minus, and our B, remember, from here B is pi over, it is pi over 4. Okay, if you factor it, okay, pi over 4. This is 4. So our answer is option D, which is correct. So that's our answer.